Hey all, it's Brian here from quantlabs.net. Just wanted to give you a lowdown on this Fastflow library project from these, looks like professors at an Italian university. If you've followed my last few postings of videos about multi-threading in C++, namely for high-frequency trading, I've come across this Fastflow, which is really powerful, and I'm quite intrigued by it. In this video, I'm going to show you what I've seen so far. I'm not going to show you how to use it or anything. Just I'm going to give you some pointers and resources that I've seen with it and my opinions of it. First of all, this thing looks really good. The thing is with this platform or library, what I'm finding is that it's faster than all the other libraries out there for TBBB, Intel TBB, OpenMP, Silk, and some other libraries, but they're currently working on a version 2, which is obviously here. I don't know if that's there is an actual stable release, but I'll get into that in a minute. But in a nutshell, as I said, I just want to show you what it is and what it can do. So let me pull up one of these diagrams here. Okay, so we have our hardware, which can be on CUDA or CPU. And then we add on our streaming capabilities, which is part of the Fastflow. But obviously, most popular in C++ and Linux is pthreads, and there's all these different paradigms for streaming networks. And then we get into the different parts of what FreeFlow offers, which is these three services. And on top of that, it can be used for all these different uses, but obviously the one that is really useful for financial people is Monte Carlo in C++. This seems to be very fast. There's some other examples used, like the Smith, Waterman, N-Queens and stuff. I might show you that. But it's quite good, pretty fast. Apparently it's got some iPhone support as well. It's not going to help me obviously at this point. So I'm not going to go into too deep into what it is. As I said, I just want to give you a rough overview of it. Now, if you come to the site, you'll find all these PDF resources at the bottom. These are quite good to explain the different types of uses for Fastflow, but namely the one that you pretty well want to focus on are the tutorials. This one, and I think there's another good one, which is this one right here. I've also typed up a brief overview of some of the stuff that you can get. So this is the sort of thing that I want people to walk away with. Okay, now we've all heard about FPGA and all that fun stuff, but I want to show you a few things that I've discovered. I'm going to let this PDF load up. But the big thing that I do like about it is it has a virtual accelerator, no different than an FPGA, but a virtual, meaning it's software. It's not needing to use any hardware. So what it does is just basically uses any unutilized processor, and it takes advantage of the availability of the processor to accelerate your parallelization processes quite a bit. I haven't played enough with it, but I'll let you read these sort of things on my website here at this URL. But this is an interesting metric that I saw. So let me just jump to page 36 here. Okay. So we're coming up to it. Okay, yeah, this is it. So here we have Fastflow with 32 cores, Intel, a pretty fast standard server. This line right here, as you can tell, if you have these algorithms that are being used, these matrices built that are utilized, this is how long it takes to run. Now, if you use the Fastflow with a Tesla board, a CUDA, Tesla C2050, and of course, I'm always interested to see how much these are worth. So if I just did a search on it to buy, let's say, that board is about $2,000. Yeah, there's a price right there on Amazon. All right, so it's not a cheap board, but look at the difference. It's 5 times faster, 2.5 seconds, and it's very, very, very fast. Sequentially, look at the difference. It's 1/100th faster. I mean, that's incredible. And here's a speed time difference as well, 271 times on some other types of algorithms. So there is obviously support somewhere using Tesla for FPGA. I just got to find it, and I would believe it's part of the version 2. Now, if you come in and download it, as of now, I guess. Let's just see. That should take you to the SourceForge. There's a tutorial and all that stuff. So yeah, so let me take you to the download. Okay, so it does say that there's version 2 is available under the download on SourceForge. Let's see what it downloads here. So it's downloading 1.1, which is I guess the more stable release. But I'm not sure where to get the 2.0, but I do believe it's under the SVN, under SVN browse, I guess. Because when you look at the age, it's not very old, 3 days, 20 hours, so it's fairly recent, but I don't think it's that stable yet. So right now I'm just going to stick with that 1.1. Alright, let's go back to the highlights. So that's the one big difference right now for using the Tesla boards on the FPGA. Like that's an incredible speed up, I guess you could say. Now, it's obviously for C++. I've been using C++ for a while. There is some talk about Java and the garbage collector. You want your multi-threading to be lock-free, which is what Fastflow gives you. There's some decent discussions about that. The garbage collector is something that could hinder you. I'm not saying it does or won't. I'm just reading what I understand it as right now. But the cool thing is, if you come here under Hack the Market, which is a fairly well-known blog for HFT dudes and dudettes, I guess, that want to get into HFT, but this one's specifically using Fastflow. Talks about it namely in the world of HFT. So there could be some movement towards this as it proves itself with R. This guy is doing the exact same thing that I'm doing with R. But let me show you how to get to there. So we have under manuals, tutorials, all this stuff. This is under the main part of the Fastflow. So you have here Hack the Market, which is this guy right here. Now he provides the source code to this blocks of code. I played with it. I just couldn't get it running. It uses Boost. So for whatever reason, my end's failing. I'm not too concerned about that. But there's some really good discussions about using Erlang and Scala and his opinions on it. Now this guy's really really seasoned. Here's his views on all these other languages out there, and I kind of take his word for it. Here's some discussion on that. Erlang, OCaml, Scala. Erlang, slow, peculiar. Doesn't support concurrency. Scala, bloated language on a bloated platform with JVM and Java. And there's that. Also, he talks about Java. Java's okay to sell servers, obviously. WebSphere comes to mind there. But not to do any offloading work on GPU anytime soon. Doesn't like virtual machines, blah, 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 blah. So he says that pretty well the only language that's really good is C++ or C. And as it says here, he talks about R, and using the same logic as I am for doing what I do with C++ and R. So I know I'm on the right path in terms of stack with R, RCPP, R inside. But now using this Fastflow, that might change things even further. And he's got a good description of what the Fastflow does. C++, if you go into the comments, there's a guy who says, why would you use like Boostazio versus the Fastflow? He says it's simpler to write. It's a lot smaller, more compact code. Honestly, I gotta say, I'm pretty impressed with the. I'm pretty impressed with this package. Okay, so I've done enough blabbing about the Fastflow with this document that I've spent some time on. And last thing before they've done comparison charts. It does always come back as being faster the Fastflow. And the odd thing, or the neat thing, is that there is obviously in HFT the movement towards 10 gigabit networks. So there's some blurbage on that as well. So let's get into the fun stuff. Okay, so I'm in my Linux environment. Now, the documentation for this 1.1, when you download it, it's kind of interesting. So let me just show you some examples. So here you got the Fastflow 1.1. When you unarch it or unarchive it, you'll get this README document, which is this guy right here. You have a variety of different example applications, but let's not start there because it gets kind of confusing at the beginning. But if you come under the tests, as I said, you don't really need to read the extra blurbage, but if you really want to get up and running really fast with Fastflow, just as I said, come under the documents here, manuals, tutorials, and then there is a tutorial. It's about a 52-page tutorial. This one right here, which will get you walking through all the different offerings that Fastflow gives you. Let me just go through this really quick. Yeah, obviously you get a hello world. There's some pipelining offered, which is really, really neat. I'm actually new to it. So essentially what you're going to do is you're going to divide up your multi-threading into various stages, let's call it. So it'll be stage 1, stage 2, and you have different pieces of code that do things. So now this is your service method, which is part of the parent class being this ff_node, which is your worker basically. And then there is this method that you inherit, and you tell it what you want in the custom code, or what you want that worker to do for your different calculations or whatever that you're breaking it up on a granular level. So essentially this is a very simple process. You create your pipeline, I guess, add the stages, run, and that's it. It's that simple. Here's some output. So this tutorial will walk you through it. Very nice, gentlemen. Now this is with the powerful part for anybody doing HFT. Okay, what's going to happen is if you come back to my document here, if you know me for a while, you may know about something called 0MQ. That's right here. 0MQ is a really neat message queuing library done in C. The nice thing is that Fastflow is actually building upon it and utilizing it. So, you know, you don't need to worry about 0MQ. If you're going to use Fastflow, it's 0MQ is part of it, which is really good. It's a really good library, 0MQ. Back to our news. So we got the pipeline happening. We got our stages as said. I'm just going to try to find some other neat quick examples I can show you. There's lots of examples in this tutorial. Now you can have access to shared objects. So here again, that is that FF node. You inherit it, and then you have the service, and then here you have this go on, which tells the framework, the Fastflow framework, to continue processing these threads. Now these are the threads. Now the nice thing about this versus something like OpenMPI is that you don't need to do all this physical management of a physical cluster and have the parent or the master connect or SSH into a slave. All this is done in memory. So if this proves the FPGA or CUDA proves itself, all this stuff can be done internally on the CUDA or the GPU or the FPGA. And if when you look at the code, it's fairly simple. Okay, and I kind of do like that. So again, if you do run a process and you have Fastflow created, it's all managed. You just define, no different than what you'd get in a Java. What do you call it? EJBs and all that. It's very similar, but you initialize and you end it. But sometimes you may want to have the Fastflow continue, so you just pass or return this go on, or you return a null, which essentially will tear down the node internally within your application. That's kind of nice. So it's all done in memory, all done in software. But you could offload it onto the framework. The Fastflow framework enables you to offload all these processes and nodes and workers onto a GPU. That's what I'm going to assume, but from what I read and understand, that's how it's done. So you can do all this locking, but the primary driver of the premise of this applicate or this framework or library for Fastflow is that it's all unblocked. So this sort of thing you don't need to really deal with. But as I said, there's the end method, and then you can also initialize. And then again, I showed you the service, and then you come into your main, and it gets kind of interesting within the main. These are different ones. I'm not going to get into those too deep. But there's a neat thing about skeletons and the Fastflow farm. So basically, you can set up a farm. Very simple. This is like geniusly simple. And all you need to do is just set your worker object with your node, and it's a pointer. Okay, and you add to it using obviously STL. You make it a vector. You add to it like this, and boom, that's it. And then you can run your stage with your workers, or you set up your farm actually here. And then you add workers to the farm, you set up the stage, and then you just add the stage with the farm. So and that's how you kick off your processes or or nodes, as far as I can tell. And then we get into something called an emitter, which you can customize what you want it to do. And then you have a collector, very powerful. Again, the worker class. I'm not going to get into that too deep. This is kind of like the schematic of what it would look like, or the graph. This is a sample output. Yeah, you can run the farm with no collector if you want. You can schedule it. You can control all the scheduling parts of it. Very powerful. And you can override certain parts of the scheduling and the load balancer. You can override. Really neatly done. And it's very simple as well. I really like this. But this is where it gets really cool. As I said before, there's the software accelerator, which is that virtual accelerator, no different than FPGA. So this is how you define your accelerator. Again, it's very simple coding, nothing too fancy. Here you set your farm, and then oh sorry, this is where you set up your accelerator right here. Similar to the farm, looks like, and you can offload. And I imagine the offload, that's where you can offload it to maybe a CUDA. If that's the case, that's probably in the version 2. That's what I'm thinking. But all I can tell you is this library is amazing. I'm glad I found it, and it's lots of neat stuff to control. But let's get into enough blabbing. Okay, so like I said, under the examples, there's different demos, but right now we're just going to look at the tests. Okay. Now I walked you through the tutorial so you can get an understanding of all the different uses that you can get with the Fastflow. Okay. They all work. I think you can install them into your NetBeans, no problem. So let me show you the code with the accelerator, farm, and pipe. Okay, this is probably something I'm going to look at because it's got all the features that I want within my potential HFT platform. This is something that I would probably be using. But as I said, if you go through the that tutorial, this should help you out. So here you define your nodes, your service. This is the logic where you put your the logic that you want to parallelize. So in my case, I might do something like the R calls. I'm not sure yet how it's going to work, but if there's different stages, I'm sure I can work something out. And then obviously you can set your priority level. Yeah, I told you about the collector. And we kick off all our stuff. We create our farm module. We talked about that. Create our emitter. Said we add our workers. And then we can offload the threads. Now, that's how it goes. Very powerful stuff. Now, doesn't stop there. So, if you come under the examples, let me just pull up my examples README. Okay, I've got all these working. Some of them are a little too involved for my needs. Let me just walk you through them. The Chillet, this SW3, simple ManoBot, don't need it. QT ManoBot, unless you're a fan of QT, which I'm not. This nCleans is an interesting demo. If I had parallelized my processor could, it's all single threaded right now. The Cholesky, unless you want to run with some MATLAB code or Octave, a MapMule. I tried all these matrices you could look at. This PB zip is kind of complicated, so I didn't bother. So when I kind of play with mostly is the quicksort. I mean, everybody knows that. Very simple. Let me just show you. It's got your simple quicksort demo, and then it brings in the different stages of complexity with Fastflow. Simple implementation, more optimized version, and then you got your blocking and non-blocking versions. This one's obviously going to be the fastest. The blocking, anything blocking, is just way too slow. But this is the gem of the feature set of Fastflow. The performance is good. Now, in terms of Windows versus Linux, apparently you can run it on Windows, but why would you? Not saying Windows is not bad, just a lot of these lower level libraries are meant for Linux and Unix-like OSs. Mac comes to mind as well, but why do that? I just like my Linux. It's nice and easy. Ubuntu's good, and I got everything all running. So, all in all, I do like it. Just want to give you a brief overview of Fastflow. I've seen some interesting things that make it look really promising in terms of processing. The version 2, I have no idea yet of what's happening here, to be honest. Yeah, I mean, yeah, it's going to be an interesting project to work with, and I do plan to move ahead with it and experiment it with my R calls using Fastflow with the RCPP and R inside. So, yeah, hopefully this will help you out. And sorry about being long-winded here, but it's been a long day going through this stuff.